Hi, in this video I will give an overview of flow control and loops in MATLAB, and I will show how these things work with some MATLAB examples. So MATLAB provide the same flow control and loops as other programming languages. So for flow control we have these if-else statements, and we have this switch case statement. And we have these traditional loops, the for loop and the while loop. And the behavior of these flow control techniques and loops are the same as in other programming languages. So I assume you know about for loops, while loops, if-else and switch statements from other programming languages. So I will only briefly show the syntax and some small examples using flow control and loops in MATLAB. So let's start with the if-else statements. So assume we have this second order algebraic equation like this, and then from mathematics we know that the equation, the solution to this equation can be like this, assuming a is not equal to 0. If a equals to 0 and b not equal to 0, then this is the solution. If both a and b is equal to 0 and c is not equal to 0, then we have this, there is no solution to the problem. If both a, b and c is equal to 0, then any complex number could be the solution. So the task is as follows. We want to create a function in MATLAB where we find a solution for this problem, and we will use it and implement it as an if-else statement in MATLAB. So we will create a function like this. We can name the function solve equation with inputs a, b and c, and then the x will be the answer to the solution. And when you are finished creating the solution using if-else, we can test if the function works as expected in the command window like this. So then we will go to MATLAB and implement these equations inside an if-else statement. So in MATLAB we start creating a new script, and then we define or use this function keyword, and then x is the return value of the function, and then equals the name of the function, solve equation in this case, and then we have these inputs a, comma b, comma c like this. And then we can start implementing these equations inside an if-else sentence. So first, if a was not equal to if a was not equal to 0, type it like this, not equal to 0, then x equals to, and then we start to implement this formula. Minus b plus the square root of b square minus 4 multiply with a c, and this should be divided by 2a like this according to the formula. So here I have implemented this formula, but as you see here, it can be either plus or minus. So here we have two solutions, and you need to implement two formulas like this. So in this case it's plus, and the other solution is minus. This is x1 solution, and this is x2. But since the return value is can only be one variable, we need to use vectors. So here we can use like this, 1 and 2, like this. So then this is for this alternative. Then we have two solutions, x1 and x2, like this. And the next, then we use else if. Then we will implement this one. If a equals to 0 and b not equal to 0, then minus c divided by b is the solution. So else if b and not equal to 0, like this, then x equals to minus c divided by b is the solution, like this. And then the next, if we have this case, then there are no solutions, so then we can just type a message to the user, there is no solution or something. So let's do that. Else if c not equal to 0, like this, then we can just use this disp in order to write a message to the user. So disp, I can just type this text, no solution. And then finally, this alternative, if all are equal to 0, then any complex number is a solution. So then we just type else and use the disp once more to display this message to the user. So any complex number is a solution, like this. And then finally we need this end. So when our function is finished, we can save it. So just type or click save and save it. Remember, the name of the function and the name of the file needs to have the same name. So now we have created our function. Now we can test the function if it's to see if it works as expected. So then we can type some values here. A equals to 0, b equals to 2, c equals to 1, like this. And then we can use our function solve equation, and then just type a comma b comma c, like this, and click enter, and then you see we got the following answer. You can try with some other values. Let's say a equals to 1, b equals to 2, c equals to 1, and then run the function once more. Then we got this solution. We can try some other values. So let's assume a equals 1, b equals to 1, c equals to 1, and then run our function once more. Then you see we got these two answers. In this case we got a complex solution to the problem. We could try one of the other alternatives. Let's say a equals to 0 and b is equal to 0 and c equals to 1, and then run the function. And in this case we got no solution, So then in this case, this part of the code was executed. Let's try some other values. And all is equal to 0, like this. Then run the function, and in this case we got this answer, and then this part of the code was executed. So now you can see how we can use if-else sentences in MATLAB in order to create quite complex mathematics like this. Next, I want to show one example where we use the switch case statement in MATLAB. So the task here is to create a function that finds either the area of this circle or the circumference of this circle using these formulas. So then we can, when we have created the function, we can test and use the function in the command window like this. So we can set r, for instance, equal to 2, and then we can execute the function with the 2 inputs r, and then the second input is when the second input is equal to 1, we should calculate the area and using this function. And when the second input is like equal to 2, then we should calculate the circumference using this formula. So let's go to MATLAB and start creating this function. So in MATLAB we just create a new script, and then we use this function keyword in order to create a function, user-defined function. The return value we could just call the variable result equals to the name of the function, calc circle like this, and the inputs argument r, the radius, and then this second option x, you can just call it x, which is either should be 1 or 2. And then we will use this switch statement in MATLAB like this, switch. So if x equals to 1, then we will calculate the area of the circle. So the result equals to pi using this formula, multiply with the radius like this, radius square, and then so case x like this, and then we use this case. So if case is 1, if x is 1, then this will be executed, and case 2, if x is equal to 2, then the result should be using this formula, 2 multiply with pi, multiply with the radius. We can also use otherwise. So if x, this one, is either 1 or 2, then you can just display a message to the user, something like this, only 1 or 2 is legal values for x or something. And then finally we type this end in order to end the switch like this. So this is our function using this switch case otherwise statement. So if x is equal to 1, this will be executed. If x is equal to 2, this will be executed. If x is 3 or another value, this piece of code will be executed. So we just save the function and the name of the function and the file needs to have the same name, like this. And then we can test the function in our command window. We can set r equals to 5, and then we can call our function, call calc circle like this, and then input r, assuming you want to find the area. Then you can do like this, and then we get the area of this circle. If you want to find the circumference, we can use this option too, and then this piece of code is executed. We can also try with an not legal value like 6 or something, and then you see the message here is shown to the user, meaning that this part of the function is executed like this. So let's summarize. We first create a function, and then inside the function create this switch case otherwise structure, and then based on x, this piece of code is executed, or this piece of code, or if x is not equal to 1 or 2, this piece of code is executed. And then you can test this function in the command window like this to see if it works as expected. Next, we will see how we can use for loops in MATLAB, and we will illustrate this using these Fibonacci numbers. So in mathematics, Fibonacci numbers are the numbers in the following sequence: 0, 1, 1, 2, 3, 5, 8, 13, etc. So by definition, the first two Fibonacci numbers are 0 and 1, and each subsequent number is the sum of the previous two. So 0 plus 1 is 1, and 1 plus 1 is 2, and 1 plus 2 is 3, etc. So then we will implement these Fibonacci numbers using a for loop in MATLAB. So we will implement the Fibonacci numbers using a function in MATLAB. So we will create a function that implement this formula according to this, and then we can test the Fibonacci function we create in the command window. So then we start MATLAB, and then we can create a new script in order to create our function. So we use this function keyword in MATLAB in order to create a function. So f is the return value, is the Fibonacci function. We can call the function we are going to create Fibonacci, and then the input could be n. So we display the, if n is equal to 5, then we just display the then it display just the 5 first number in the Fibonacci order. So let's start creating the function. So the first two number is MATLAB uses vectors. We can define f1. First element in this vector should be equal to 0, and the second element in the Fibonacci numbers should be 1, and then the next numbers should be calculated according to this this formula here. So then we can implement this using a for loop. So for, and now we have defined the two first elements, and we can start on 3. So you just define a variable k, which is typically used in a for loop. Either we typically use k or we use I for this variable inside a for loop. So then the for loops should be running from 3 to this number n, and then we can define this end, And inside the for loop we define this formula. So f of k equals to f k minus 1 and then plus f of k minus 2, like this, according to this this formula here. So the next number in the Fibonacci number, next Fibonacci number is according to this formula. So it's the sum of the two previous numbers in this sequence, and this can be implemented like this in a for loop. So this is our Fibonacci function. Then you can just save it like this, and then you can test it in inside the command window. So then you can type n equals to 4, for instance, and then we can type or execute the Fibonacci function. Like this, and the input will be then n. So then you see it displayed the first 4 numbers in the Fibonacci sequence. Then you can type n equals to 10, then execute the function once more, and then you see you got the 10 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 first numbers in this sequence. So this is how we can use for loops in MATLAB, and for loops are one of the most used loops and features in MATLAB. So I guess in almost every program you typically need a for loop. So this is how we implement it in MATLAB. In the next example we want to use a while loop, and in this example we want to create a script, or in this case a function, that creates the Fibonacci numbers up to a given number. So let's say we set the max number equal to 2000, and then you can execute the function, and then it will only display the Fibonacci numbers up till this max limit. So let's see how we can do this in MATLAB using a while loop. So then we have our previous Fibonacci function here, and then we can just start by so just change it to Fibonacci 2, and then just save as, and Fibonacci number 2, like this. And then instead of a for loop we should use a while loop. So you just replace the for with a while. So when this function is less than this max value, like this, so this max value should be the input to the function. Then since we have k here 1, 2, 3, then we start k equals to 3, like this, small k, and here is the formula, and then in each iteration you can just increase this k with 1, like this, using this syntax. So I guess this is all. We implemented the Fibonacci formula within a while loop instead, and we save it, and then we can test it in the command window. We can set max equals to 2000, and then we can execute the function like this. So the name of the function, in this case Fibonacci 2, and then the input, which is max, and in this case max is equal to 2000, and then you can click enter to execute it, and then you see it was executing the Fibonacci number up till this limit. So in this case it also included this one, like this. You can improve this function if you want to, not to include this value. So that is a challenge you can try by yourself. In the next example, we will improve this calc average function we have created earlier in a previous example. And this calc average function in the previous example, it just got the average from two numbers. But now we want to use a for loop. So the input to the function can be a vector of whatever length you want. So that with using this for loop, we can make this function more general, and it can handle any input of the input can be of any length. So let's see how we can create this function in MATLAB using a for loop. So in MATLAB we can just create a new script and then start using this function keyword in order to create this function. So the return value, we can call it average, AV, equals to the name of the function. And we can call the function average2, since this previous function was called average2, and each function or file needs to have a unique name in MATLAB. And then the input could be just this x, which is in this case can be should be a vector. So then we use this for loop to implement from k equals to 1 to n, like this. And the sum, I can call it my sum, equals to the previous sum plus the next value in this x vector. So in this case, since it's inside this for loop, we can just set x of k like this. So this is basically our formula. And then when we go through all loop through all the numbers in this x vector, we just get the average by take the my sum and divide it by n, which is the number of elements in this vector. So then we also need to define n, and then we can just use this length function that just gives number of elements in this x vector, like this. And also, since this is my sum, we need to have an initial value, so we can just say set my sum equals to 0, like this. So basically this is the function. So the input is x, and then we find number of elements in this vector, and then in each element we summarize all the values in x, and then after the for loop is finished, we just divide by n in order to get the average value, like this. And then we can just save it, calc average2, and then we can test it in the command window. We can just get some values, x equal to these numbers, and then the whole idea is to find the average value of these values in the x vector. And then we can use the function. So the average value is equal to the calc average2 function, and the input is x, like this. And then you see it calculates the average value based on these values in the x vector, like this. This is how we can use a for loop like this. in order to find the average value of a vector. We can also check the results to see if it's correct using this built-in average function called mean. So mean of x, and it gives the same value. This means that our function is correct. So let's summarize. We create this function, calc average 2, and then we implemented the formula in a for loop like this. And then after for loop, we found the average value of all of the elements in this x vector. And then we could test it in a command window like this. In the next example, we want to improve this function using an if-else statement. So assume we have this vector x, but we only want to find, let's say, so in this case we have this vector of 4, 6 and 12, but let's say we only want to find the average of the values that is below 10. So let's see how we can do that in MATLAB using this if-else statement. So we use our previous function. We can just save it with a new name, save as, and then we can call it calc average 3. Change this one to 3, and then we wanted to check this, just find average of values but less than this this number n. So we add on second input to the function like this, and then inside the for loop we can create this if sentence. So if x of k is less than this, we shouldn't use n, since we already use n here, then we could change it to this. We can use L. So if it's less than L, then we should do this calculation. We also need to include include a new variable here. We can call it total and set start value to 0, and then inside this if sentence we can set so if this is this if is true, then we set total equals to total plus 1 like this, and the end, use this is end. And then instead of this one, instead of dividing by n, we just divide by this total instead. We can save the function, and then we can test it there. We can set x equal to 4, 6, 12, and then now we want to find average of the values that is less than, let's say, this case L is, so this less than, in this case we can just set it to 10. Then we can use our function calc average 3 like this. Yeah, we need to include this comma L like this. Can you see? So our vector was this 4, 6 and 12, and we want to discard numbers that are larger or equal to L. In this case L is equal to 10, so this shouldn't be included in the average. So then the average should be only for these two numbers, and the average of these two numbers is 5 in this case. So you see our function works as expected. So this is how we can implement both for loops and if sentences in your MATLAB code. So that's all you need to know about flow control and loops in MATLAB. So good luck with your MATLAB.